Okay, good. So there will be, let's see, I don't think I can create polls through this. No, I can't, but that's okay. Because at the end, we'll have a discussion, we'll have a few breakout rooms, and there'll be. So please pay attention, because if you don't, you will look silly at your breakout room. So today we're talking about this big thing about peer-reviewed papers, publications, things like that. And at the end, I'll share some of the stuff that my group is doing that we are publishing and the process for that. But we wanted to start out with the following questions. Why do scientists publish their work, and what separates peer-reviewed literature from popular literature? Open-ended question. People can unmute themselves now and talk. Anybody want to answer the first question? What's one of the reasons why scientists publish their work? You can just unmute and talk.
To share their findings and share what they found out.
Okay, to share their findings. That's awesome. Science is a dynamic community. Sometimes people are publishing for their resume, but most of the time scientists publish to disseminate to the greater community, right? If I'm an organic chemist and I find a new reaction or I find a new way to make a molecule, I want to share that with science so that other people can benefit from that knowledge. Why else?
Maybe to develop their work based on the feedback that they get from the scientific community. Okay, good. So sometimes something to a peer-reviewed venue is a self-check to make sure that your science is going in the right direction. Why else?
To make sure other scientists don't repeat the same thing when it's already been done.
Exactly, good. So to make sure that other scientists don't have to repeat the same experiments, and more broadly also to protect your work. When you publish work, it's copyrighted to the authors. And when we share figures from our published work, my students can write in the slides, copyright their last name, copyrighted to them. Yeah, if you have already invented the wheel and you publish the paper in Nature about how wheels work, don't save your fellow caveman a little bit of stress, and they don't have to invent the wheel again. What separates peer-reviewed literature from popular literature? Can somebody give me an example of popular literature that you might come across on a daily basis? Even if it's scientific popular literature. I'm not talking about Facebook, or I found out this week that there's this thing called TikTok that you Gen Z people like to use. I'm not talking about that. I'm talking about scientific literature, things that are science related. What is the difference between peer-reviewed scientific literature and popular scientific literature? I'm not talking about the book in your English class of Mice and Men or whatever, but science, yeah.
I think some examples of popular scientific literature are like the web pages online if you want to look specifically about a certain disease or a certain topic, like they're magazines that publish articles to inform the public about a certain type of like scientific experiment or something.
Good. That's good. Popular New York Times, the science section, yes, it's popular. Sometimes people have blog posts that are scientifically oriented. We see a lot of this related to COVID these days. And that's unfortunately the source of a lot of misinformation as well as information. Even journals sometimes have a popular science section for the lay public. Some of you are typing very, I can't tell who it is, but if you're typing violently, Mayo Clinic is probably, well, that's based on a lot of peer-reviewed literature. That's more like a scientific encyclopedia or medical encyclopedia. But if you've ever heard of Science Direct, that's popular literature. The difference is that in peer-reviewed literature, the validity of the information that's presented is made on the basis of the consensus review of other scientists who have looked and inspected the work and determined that it is reasonably rigorous. Okay, scientific peer-reviewed literature has a different standard of reporting accuracy. anybody can go out there and start a, I don't know, myscienceblog.blogspot.com or WordPress. And those sources of information are not necessarily bad, but they don't stand the test of credibility to the same extent. And so the comments that are being made in the chat are quite valid. So there are different journals that people like to publish stuff in, and maybe you've heard or read papers from some of these journals. There are ecumenical journals. Does anybody know what ecumenical? And that's just the term I coined for this slide. It's not in the dictionary somewhere. It's, ecumenical just means broad. So there are some journals that will publish high quality research from any and every discipline, including some of the highest impact journals that we have today, Science and Nature, PNAS. And then there are discipline specific journals. So there are many journals which are catered to one specific discipline. For example, the Journal of the American Chemical Society. Guess who publishes papers in JACS? Anybody want to guess?
Chemists.
Sure, chemists, thank you. Transactions in Artificial Intelligence, which is the journal published by the IEEE. That is, and I think Phil Mui's group has a paper in that journal. That's a journal that people interested in AI would publish in. If I were to submit a total synthesis project to Transactions in Artificial Intelligence, it would get rejected right off the bat because it's not specific to that journal's purview. Now, this can also work the opposite way around. I had a paper earlier in grad school. I had a paper that got rejected from Nature. It ended up getting it into one of the other very high impact journals that's also run by Nature. But it got rejected from Nature, not because of the nature of any of the science, not because they didn't like the science. They thought the science is awesome. They said, this is cutting edge work, awesome, fantastic stuff. But they rejected the paper because they said it was specific, because they said it was specialized. They said it was not broad reaching enough. So sometimes, even though you have high quality work, it may get rejected from a high tier journal, surely on the basis that it may not have as broad of a readership as these journals are looking for. Okay, so who's involved in the publishing process? There's all of you who I hope you all aspire to publish a paper. How many of you have co-authored a paper while you're here at ASDRP? No hands are raised. No. Really? Okay, so there are two people here. How many of you are currently writing up a paper? Good. So many of you are part of this process. So who's involved in the publishing process? There's all of you authors, and then there are the people at the journal who call the shots on things. The editor-in-chief, there's a reviewer, and there are copy editors. The editor-in-chief is responsible for overseeing the scope of the journal, overseeing general submissions. The editor-in-chief, or usually the managing editors of a journal, are the ones who are responsible for making sure that a submitted work is coherent and adhering to the guidelines set forth by the journal. And they're usually the ones who conduct what we pre-review. So before a manuscript gets sent out to peer review, a series of editors will go through the paper and make sure it is appropriate for the journal before they either use or waste other people's time. Reviewers are people in the community. These are scientists, these are academicians, these are people from industry who set aside part of their time to move forward the needle in science. And these things are often voluntary. Reviewers are not typically compensated for their work. A friend of mine, who some of you have met, is a reviewer for Bilstein, a reviewer for Simlet, for Synthesis, for Tetrahedron, and also for a high school journal called JDI. But these are experts in the field who spend their time reviewing papers and refereeing, making sure that they're good. And then the copy editors are people who make them. So they're the artists, the artistic bunch of the science group. Types of publications, there are two general classes of peer-reviewed articles, review articles and original research papers. Review articles don't disseminate new information per se. Instead, they focus on a retrospective analysis of existing. So a literature review typically encompasses a particular time frame, and say we're going to say let's write a review paper on, I don't know, CH amination chemistry in the last 5 years, and one would then go through all the literature on CH amination chemistry and put together a summary of that in a review article. A review article does not disseminate your original research results, but it is a distillation of and an interpretation of existing work. A review article is not just a summary. Review articles contain perspectives. So a good review article is not just summarizing where a field is and what things people have published, but also speaks directly to where the field is going. Metadata analysis is, actually, Ajit, this is a great question. Ajit is asking in the chat window, what is the percentage of publications that are original research reports? Well, it actually depends on the journal. Most of the time, the difference between review articles and original research reports are separated by journal. So in the chemistry world, there are journals that just publish review papers. All the other journals, including places like JACS, Journal of Organic Chemistry, Journal of Medicinal Chemistry, those are all original reports where people are disseminating original data and conclusions drawn from their own experiments. So by and large, unless you see in the title it's a review paper, it's an original research report. A majority of articles that are published, I forget the actual percentage, it's probably upwards of 80% are original research reports. Anybody know what a metadata analysis is? There's a lot that's published with COVID right now. Nobody. So a metadata analysis takes existing data that somebody else procured. Oh, Rohan, do you want to chime in? Maybe not. Okay, so a metadata analysis is a retrospective reanalysis of data that somebody else procured and analyzed, and you're simply constructing additional hypotheses and conclusions based on that data. Okay, the difference between a full research article and a communication is typically the length. A communication article is a short, action-packed article, which typically undergoes a faster review process. So we're talking about months instead, weeks to months instead of months to years. Whereas full research articles are more in-depth, more drawn out. And then there are other publishing venues, which we will not have time to talk about. I know some people in the John Nicchia lab are writing a book. People in Phil Moo's group have written a book before. And some people in my group are writing application notes and white papers in collaboration. So these are other publishing venues that we're not going to talk about today. Today I will focus on original research reports as a means of publishing work. Now here's a question, not all journals are created equal, okay? A paper in Science or a paper in Nature is a much more impactful paper than a paper that's published in the International Journal of Pharmaceutical Sciences. And there's no real good way to put a metric on the goodness of a journal. How do you know how reputable a journal is? Some journals are very reputable. I have a personal problem with MDPI journals because I think that they have some unethical publishing processes. And so if you're in my group, we will never submit material to an MDPI journal. But one way that people have constructed to attempt to put a metric on this is this thing called impact factor, which is a numerical proxy for defining a journal's quality based on the number of citations divided by the number of citable articles. Okay, so basically how much people are talking about your paper. Now, what's a problem with impact factor analyses of a journal? By the way, this is just a quick exercise. You can Google these numbers. Does anybody know what is the impact factor of Science and what is the impact factor of Nature? And what is the impact factor of JACS? I want you guys to put it in the chat window. Just Google it. What is the impact factor of Science, Nature, and then the Journal of the American Chemical Society? Those are all high impact journals. Science is 47.73. Wow. How about Nature? 49.96. It exceeded Science this year. That's crazy. How about JACS? JACS is 15.42, which is a very high impact chemistry paper. But what is the danger with impact factor? And if you want to read more about this, I would recommend that you read the Simons paper in Science, published in 2008, a critical review on what does impact factor actually mean. What is the problem with judging a journal sheerly on the basis of impact factor? Okay, can people unmute maybe, and let's make this verbally interactive?
So impact factor can vary heavily based off the field. Like, for example, medicinal chemistry has especially in cancer research, has significantly higher impact factors compared to other fields, while smaller fields like lithium batteries, etc., will have significantly lower impact factors if they're more specialized.
Okay, good. And then Colin has a different comment, but these are the two reasons that I was looking for. The first of which is impact factor is highly field, or citation is highly field dependent. If you are in a field that's massive, okay, for example, COVID-19 research, gee, that's massive, right? In fact, COVID-19 has actually inflated the impact factor of a number of journals where people publish a lot of COVID papers in, because people have been citing like mad. Whereas some other fields, such as physical organic chemistry, gee, how many physical organic chemists are out there? How many organic chemists are out there? Much fewer than people who are interested in COVID-19. So it becomes a little bit misleading. And secondly, Colin made this comment in the chat window, there's a lot of trend following. It becomes a self-fulfilling prophecy. People cite papers in their articles from high impact journals because they're high impact, but that means that they end up being higher impact because they get cited more. So it becomes a self-fulfilling prophecy almost. I would recommend reading the Science paper, 2008 Simons. It's a very good critical review on this. Okay, so then let's ask the question, when can you publish a paper? Obviously, there's a lot of people in this audience, many of whom have published papers. I see some people in this audience who I might call upon. So if you've co-authored a paper with me, you better get ready to speak up. But not everybody
Wait,
has.
let me change around volumes because Edward is so covering up.
I'm what? Ratush, you're unmuted.
Yeah, sorry, I was just discussing
Volume?
Doctor.
Yeah, good. When does one publish a paper? We get this question a lot from your parents. Are you going to get a paper by the end of the semester? And what is the answer? It's a big maybe. Dependent on a lot of factors. It depends on a lot of factors. And the defining factor of scientists when we decide when we're going to submit a publication is the following. Novelty of science. What's meant by novelty of science? And how do you define novel? Something that is new. Okay, so that's good. So Jeff is saying that something that is new. That's a very dictionary definition. Scientifically speaking, what does this mean in terms of, rubber on the road? How new does it have to be? Because one might argue in science, nothing is ever brand new. Yes, if you're working on a COVID-19 vaccine, you make a new vaccine. Well, making a vaccine isn't new. And the technology that you use to make that new COVID vaccine, the vaccine itself might be new, but the technology is like 3 decades old. In fact, how many of you know this, that the mRNA vaccine delivery technology has existed for several decades? Okay. So science is always additive. So we're always adding material to existing science, but there has to be new information, new data, and new conclusions that are drawn from that data that have not previously surfaced in science. That is the #1 defining criteria for something being publishable. Okay, if you simply reproduce somebody else's work, that's not publishable because that's not novel. It's fantastic, but it's not novel. Secondly, rigor and reproducibility of results. And I have pictures of some of my lab members in this photo. Does anybody recognize anybody? Yikes. Nobody wants to get called out. Okay, good. So, and I put these 3 people here because these 3 people, maybe they thought that I was being very mean, but we were working on a set of compounds that we're now wrapping up a publication on that are anti-nematode compounds. They kill nematode parasites through calcium ion channel dependent paralysis. And we were working with Rob Downing's group on this project using image analysis, and Nathaniel was very instrumental in providing a script to do that, on how our compounds, trying to quantify how well our compounds paralyzed nematode parasites. And that's very difficult to do. Nematodes don't really behave that well, right? They're kind of swimming around and they kind of float off the image and they kind of float back into the image. And we had a big reproducibility problem, because if you get the nematodes on day 1 and you wait 5 days to run your experiment, all of a sudden the experiments from day somebody's listening to a lot of music. And I put these 3 people here on the slide because they got to learn firsthand the importance of reproducibility. In fact, I made them redo every single experiment to publish that paper. They sat there, they ran all these beautiful experiments. It was not reproducible, unfortunately, because of a variety of factors that were not taken into consideration. So they sat there for the next 2 weeks at that microscope, spending what, 5, 6, 7, 10, 12 hours at a time at that microscope that Nikki's standing next to, reproducing those results. And I think Nikki's there right now doing that experiment. But good job to those people. And lastly, conclusiveness of research. You might do a lot of research that may never be published. And that sounds very like, yikes, I'm going to do a lot of research that may never be published. I probably run upwards of 20 to 30 experiments a week in my life as a chemist. And probably about 1/20th of the experiments that I perform are going to end up in a publication. Because a lot of things simply do not work in science. And that's the nature of science. And unfortunately, we live in a community that does not publish stuff that does not work. One has to have conclusiveness of results to publish. You can't publish stuff that either doesn't work or you have no clue what's happening. Okay, so the peer review process, what's meant by peer review? Well, I'm going to leave this up here while we talk about this, but you submit a paper that goes to the editor of a journal. The editor decides whether to reject it flat out, in the case of my Nature paper, because they said it was good science, but it was too specialized for synthetic organic chemists. Or they send it to reviewers. These reviewers are scientists in the community who are taking time out of their schedule to review and referee your paper. The reviewers will then critically analyze every detail of your paper and determine whether they're going to accept the publication or they're going to reject it. And that review process might take several weeks, several months sometimes, depends on how much time they take deliberating. There is one journal that we'll talk about where in part of this review process, the reviewers reproduce every single data point in the submitted article. Isn't that crazy? They go through every single number in that article and they make sure every single point is reproducible by multiple operators after you submit the paper. So that might take a long time. They might reject your paper if it's of poor quality. If it is accepted, generally that's not the end of the publication cycle. Typically they'll accept it with revisions. And this is a sample. Oh, I'll show that in a moment. But typically that is, you're given revisions. The reviewers say, well, you need to fix the following. We want to see these additional experiments being performed. This should be reworded in this way, etc. And after a few rounds of review, this takes several months, it then goes into production where the copy editors make it pretty and send it off to publication. So when you're preparing a manuscript, what must be referenced? How obviously, when you're doing science, you are contextualizing this within the confines of your discipline. But what should you reference in the introduction of your paper? And by the way, people have gotten publications rejected on the basis of either incomplete or insufficiently rigorous citations. Can you believe that? A reviewer could reject your article on the basis that you did not reference things properly. So Collins says that you must reference all previous work. That's a little bit too generic, because if, let's say I was publishing a paper on I don't know, some of the people in my group last night until like midnight, we were writing a paper on our neuroactive compounds. Some of you heard about Erica's stuff, colloquium a few weeks ago. But if I were to publish or cite every single paper that's related to rivastigmine, I would have like 50,000 citations in my introduction. Okay, so this is a less trivial of a question. Anybody else? Maybe people mute and talk. What must be referenced? What information in an introduction, and we'll read some sample papers in about 10 minutes, but what things in an introduction can need to be referenced? If I make a statement, let's say we're writing a paper about a new COVID vaccine. If I make a statement, prior efforts at development of an mRNA vaccine against SARS-CoV-2 have demonstrated a great deal of clinical success and have since become FDA approved in the United States and elsewhere. If I make that statement, does that need to be referenced? So yes or no?
Yes.
Why would, okay, good. I'm good that everyone agrees yes. Why yes?
Because it's like the information that you like, or statistics that you found by researching. It's not like your own motivation, or like when you're talking about like your own discovery, it's like what you found out there from the internet or like other journals or articles or something like that. Because it's like a statistic, you have to cite it.
Yeah. Sorry, let me deal with this real quick. Yes. If it's not obvious or if it's not yours, you have to cite it. In fact, some of you heard about JN at our last colloquium and the big mess that he created for himself because he did not properly cite his source. Everything that's not self-evident, if it's not obvious and trivial, for example, if you say the sky is blue, that's a trivial fact. You don't have to cite a paper that's saying that the sky is blue. Anybody can go outside and observe it. If it's not trivially self-evident or if it's not yours, you must cite it. How does one start a paper? These are a bunch of random questions that are not necessarily related to each other. How does one start a paper? If you think about beginning a paper, the opening of a paper, what are some things to consider when you start? Okay, not the abstract, the introduction. When you open up your paper, what is important to establish?
What you're researching and why you're researching it.
Okay, so what it is that you're doing and why anybody cares about it. Scientists have very limited time. Yes. If you're a scientist and you're a day in the life of a scientist, my eyes come across the titles and abstracts of probably around 100 papers a day. Okay, I don't read 100 papers a day. I probably read 10 of them. But my eyes glance across the titles and abstracts of about 100 of them. If something in the introductory sentence does not interest me, or in the title does not interest me, I'm not going to read it. It's simple as that. And it goes to the same as reviewers. Okay, if you have a shoddy title or a shoddy introduction, they're going to stop reading right after the introduction and say this is garbage. Okay, to establish what one has done, why it's important, why people care about it. Think about your readership. Who is it that you're trying to communicate to? Okay, are you assuming background information? And that might depend on the venue of a journal. And finally, what conclusions are valid to draw? What is the danger of overreach? Does everybody understand what is meant by overreach in drawing conclusions?
Is it like over concluding like statements and like saying like stuff that are beyond like your research?
Exactly, and that's something that you want to avoid. You must avoid as a writer, as a hopefully future publisher. You can only make valid conclusions that are well supported by the data that you have. So, for example, okay, if I develop a compound, and people in my group have done this already, if we develop a compound that kills cancer cells in an ex vivo assay, Okay, so we run these experiments on human leukemia cells, and the human leukemia cells MTT results, slammed, they're all dead, right? So we killed leukemia cells, fantastic. And let's say these things also cure colorectal cancer cell lines. Can we say we've developed a new therapeutic for cancer? Yes or no? It's a yes or no question. No, why not? Why not? Anybody?
Because you haven't tested like the how good it would work in like their therapy session. You just discovered that it might work. So that would be like a what's next for like your research rather than like a conclusion for your research.
Excellent. So we could say these results lend themselves to the development, the future development of therapeutics. But all we did is we found that these compounds killed cancer cells. That doesn't mean it's a therapeutic yet. It's an important result. Okay, but you must be careful that the conclusions that you state with absolute confidence are backed by the data that you present. And by the way, part of the peer review process, I put this figure up here because this is kind of how a peer review feels like for a scientist. When you submit work with your advisor, that work is not only tied to your name for the rest of your career and your posterity, it is also tied to our name. The students that co-author papers with me, those papers are tied to their names and to my name and reputation for the rest of my career. So this is important. You're being inspected, and you should be certain that any result that you state is conclusively and irrefutably and unequivocally backed by data. And that anybody looking at that data with fresh eyes would arrive at the same conclusions. If that is not the case, it is not ready to publish. And I can't tell you how many times I've sat through meetings with group members in my lab where that was a problem, where we didn't quite think things through, and we're about ready to publish a paper. This just happened yesterday or a few weeks ago. About ready to publish a paper, and then I realized that some people had not done a key experiment to verify that a chemical intermediate was what we thought it was. And it turns out it may not be. So now we're back at the drawing board. Instead of submitting this paper, we're gonna go back and run maybe 2 dozen more experiments for a few more months. There's different types of peer review, single blind, double blind. Sometimes you know who your reviewers are, sometimes you don't. In some of the higher end journals, you actually have to state who you want to referee your paper. So when you submit papers to, say, Beilstein, the Beilstein Journal of Organic Chemistry, in your cover letter, your advisor has to list a number of scientists that could referee this paper. You're picking your reviewers. And one might say, gee, well, that isn't that kind of not good? Well, scientists have a code of honor, and that is that you're going to pick reviewers who are going to objectively view your work, who can speak with expertise to the area of science that you are talking through. Even when you submit to a high school journal, your reviewers are postgraduates, they're PhDs, they're postdocs, they're scientists in industry. And these are people who have advanced degrees in the area that you are submitting things to. So for example, this is a paper that, that the MLDD group got accepted a few weeks ago, a few months ago actually, development of a novel machine learning platform for spectral trends among NNRTI HIV reverse transcriptase inhibitors. Bhavesh is now an undergraduate at UC Riverside, but this is with Robert and myself. And you know, our reviewers they're not soft hitters. This is a high school journal, okay? Our reviewers, there's an MD candidate, there's a research associate from Harvard, and there's a postdoc from Harvard. The paper that my group just got accepted 2 weeks ago, one of the reviewers was actually my coworker. He did his PhD at IIT and has 2 postdocs. So these people are very much so experienced in their field, and they will be able to speak critically about the results. In fact, when we submitted that paper, what the reviewer did is he went through the supporting information and inspected every single peak on the NMR spectrum for 4 days straight. He did nothing else but stare at people's NMRs. Okay, so your reviewers are going to be experts who will critique your work and who will inspect every corner of your work. That's frightening. But that's also the beauty of peer review, because when you read a peer review paper, then you can sit there with confidence and say, whatever the heck I'm reading has been thoroughly vetted by skilled scientists who are qualified to speak to the science that is being shared. Okay, we're going to talk about reproducibility. This is a very important thing that is very near and dear to the heart of chemists, but also to the hearts of other scientists. Let me see. Well, real quick, timeline, pre-reviews like 2 to 5 weeks, peer review 1 to 6 months, revisions maybe up to a year, longer, copy editing 1 month. If you're open for publication, there's no such thing as a quick publication. The publishing process takes between a half year to 2 years, depending on a number of factors. And some of you mentioned these things. What defines how quickly you publish a paper? Some of you are listening here. How can I publish a paper? Well, publishing is an opportunity that's before all of you here at ASDRP. Okay, as a researcher here, you have an opportunity to co-author publications with your advisor. But some of the defining factors that will dictate how the quality and quantity of publication that you produce is the nature of your discipline. Some disciplines publish a lot faster. It's not unfair, that's how it is. For example, I have people who are working on total synthesis in natural products. Most total synthesis chemists, their whole PhD, their 6 years in grad school, they publish 1, maybe 2 papers. Isn't that crazy? How many of you think that that's crazy? Because a typical total synthesis takes multiple people, sometimes a dozen of people, sometimes a decade to complete. That's crazy. That's one project. And so some disciplines like total synthesis and natural products, those are inherently very long drawn. Likewise, if you're working with animal models, there's a saying, and some of you will get to listen to Dr. Valentine when she gives her guest speaker probably in April. But there's a saying that if you work with animal models, you should add 2 years to your PhD, because it is much slower to publish if you work with animals, because you have to grow your animals and it takes them months to grow. And lastly, and perhaps most importantly, this is the part that's in your hand. How hard you work and your skill set and that of your peers. Okay, you have a choice between either publishing nothing or publishing work, in which case this will require a large amount of your time, effort, and energy. I'm going to randomly pick on one of my group members who is hopefully here, who has co-authored a paper with me. It's not here. Udbov. Can you comment on the amount of work that is needed to reach a publishable manuscript?
It depends on like the specific topic or like what specific area it is, but like usually a few months to even a year.
Yeah, so we have
or more.
We have methodology projects that publish work within a few months. My group, we have a large portion of our work is synthetic methods now, and catalyst development and small molecule synthesis. So those things publish a lot faster, and we turn out possibly maybe about a dozen to a dozen and a half papers per year that are all student co-authored. But these things are all factors that are not necessarily uniform. So you can't necessarily say, all right, Ed's group publishes 18 papers in 2020. I don't remember, 15, 16, I don't remember. Publishes 16 papers in 2021. And then, I don't know, Jane Doe's group only published 2 papers. Gee, Jane Doe must be a terrible advisor. That's not the case. Sometimes the discipline just takes longer to publish it. And people who are synthetic chemists are impatient people, and it just so happens that our work gets published fairly quickly. Okay. At the end of a paper, there's typically a supplementary information, supporting information. How many of you have ever read the SI of a paper? Show of hands. And good. So 4 people out of 190 have read the SI. 5, 7. Okay, good. All right, 9. I'm a little disappointed. But sometimes if you look at a paper, there's going to be material that doesn't fit on the actual manuscript. Experimental details and painstaking detail that are nevertheless an important part of the publication. So for example, if you're a computer scientist researcher, you might submit as part of the SI your code or your data set that you use for your machine learning or whatever. In fact, almost every single one of our MLDD papers that I've co-authored with Mr. Downing's group, we have submitted annotated code as part of the supporting information. If you're a chemist, you must have rigorous characterization. In other words, if you report a chemical structure, everybody else who reads your paper should be able to read the NMR and say that structure is assigned correctly. And I know many chemists whose entire careers have been destroyed by a single mischaracterized molecule because somebody read their SI and said, gee, they assigned the structure wrong. That chemist is useless. If you're a biologist, it might include experimental details, instrument specifications. If you use flow cytometry, you know, how do you program the instrument? If you work with cancer cells, where do you get your cancer cells from, et cetera, et cetera, et cetera. The bottom line for an SI is that anybody who reads the paper should be able to reproduce your work in exacting detail. So for example, this is part of the SI of the paper that we submitted that we just got accepted a few weeks ago in a journal. This is with Alice and Selena and Jesslyn and Aishi, Tiffany and others. In my group, when we publish synthesis with yields, those yields have to be corroborated by multiple operators internally within our group. And anybody who reads this SI, this is the exact protocol that came out of somebody's notebook, okay? There's a lesson in here for record keeping. This came out of somebody's notebook. And this is the exact procedure for how to make compound 2 from compound 1, including where we got the chemicals from and their degree of purity. That's a lot of detail. And this is only page 1 for this one experiment, this one reaction. This was 6 pages. That's crazy. Isn't that crazy? How many think that that's crazy? 6 pages for one reaction. So that anybody on Earth can reproduce this exactly. And why are chemists so obsessed with reproducibility? This is a quote from a very good paper, and I've put some references in this slide for people who want to read more. This is a quote from Marcia McNutt. That's a fun name, McNutt. Don't you wish you had a name called McNutt? In Science 2014 about why reproducibility is so important. Reproducibility, rigor, transparency, and independent verification are cornerstones of the scientific method. In other words, if things are not reproducible, science will not go forward. And if your experiments are not reproducible, they're not publishable. Of course, just because a result is reproducible does not necessarily make it right. And just because it is not reproducible does not make it wrong. A transparent and rigorous approach can almost always shine the light on issues of reproducibility. When I started graduate school, there was a person who was famous for having magic hands. In other words, the yields would always be higher in this person's reports than what anybody else could reproduce. Guess what? We never got a person for experimental procedures or for experimental advice because we know that all of his experiments are hogwash because they're not reproducible. This is that important for scientists. And any scientist will know that one way to very quickly destroy reputability in science is to have a single, not reproducible procedure. So that is so important that here's a journal, Organic Synthesis. This is one of my favorite journals. It's a very old journal. And the editor-in-chief is Rick Danheiser. Rick is on the faculty at MIT. I had the opportunity to attend one of Rick's seminars previously. But Rick and others in the editorial journal board of OrgSyn are obsessed with reproducibility. Okay. Does anybody, I'm going to call on somebody. Can somebody, people are all paying attention because I'm going to randomly call on somebody's name. Adelina. Is Adelina here? Adelina.
Yeah.
Good, you're paying attention. Can you read the quote in the middle? This is on the homepage of OrgSyn.
To be absolutely certain that each set of directions can be repeated, every experiment has been carried out in at least 2 laboratories. Only after exact duplication of the results in both laboratories are the directions considered ready for publication.
Okay, so if we submit a paper to OrgSyn, what's the first thing that people at OrgSyn do? Anybody want to guess? Adelina, pick somebody random from the audience who will be called upon to talk about what you think OrgSyn does.
Max.
Max, you've been called upon. What does the journal OrgSyn, I don't know why people are leaving, this meeting is not over yet. What does OrgSyn do the moment that they get a paper for that people want to publish in their journal? What does Rick Danheiser do at MIT? Is Max here? Yikes, Max is not paying attention. That's really bad. Adelina, why don't you pick on somebody else who's hopefully paying attention?
Kira.
Kira.
They probably try to reproduce your results.
Yes, exactly. Rick Danheiser's group at MIT, when they get a paper for OrgSyn, he has a few of his scientists try to reproduce every single number in that paper. And if they can't reproduce it, what happens?
It doesn't get published?
It gets rejected. And the author gets a nasty email about things not being reproducible. And that is reproduced multiple times. So it's not just one person reproducing it. They actually reproduce, I think the actual number is 3 times. 3 different people on 3 different points in the United States have to be able to reproduce the protocol in exacting detail. And so OrgSyn actually requires that you even have to specify the size of glassware that you use. Isn't that crazy? You have to specify the glassware. Like I used a chromatography column that was 1.3 inches in diameter and 8 inches long. That's wild because reproducibility is that important for science. So important. I'm going to skip through some of these things. Some of you have seen these slides before. We talked about this back in October. But in 2020, there was a very big incident published in Science with Frances Arnold, who's on the faculty at Caltech. She actually won the Nobel Prize for chemistry in 2019, and I got to touch her Nobel Prize. We had coffee with her, and I got to touch it. It's just a piece of metal. Frances Arnold got a lot of heat back in 2020 because this is a paper that was published in Science by In-Ha Cho and Zijun Jia, who and a few weeks later, somebody in her group said, "Gee, Frances, we can't. That paper that In-Ha and Zijun submitted to Science that got published. Maybe we're really bad scientists, but we can't get the same results." And so they did a lot of investigation at Caltech, and Frances eventually retracted the journal with this statement. By the way, if you ever have to do this, this is your death sentence in science. That is the end of these people's scientific careers. In-Ha and Zijun were subsequently fired from Caltech, and good luck to those 2 people for finding a career in science. They had to retract this paper because somebody want to read this. Who wants to read this? Kira, you're the last person to speak. Pick somebody random from the audience who's hopefully paying attention.
Ahmad.
Who?
Ahmad Gandhi.
Ahmad Gandhi, you've been chosen. Please read the...
After publication of the report, cite selective enzymatic CH amidation for synthesis of diverse lactams. Efforts to produce the work show that the enzymes do not catalyze the reactions with activities and selective claims. Careful examination of the first author's lab notebook then revealed missing contemporaneous entries in raw data for key experiments. The authors are therefore retracting the paper.
Yikes, isn't that a big yikes? How many of you think that's a big yikes? Yeah, that is the end of those people's scientific careers. They were fired from Caltech. Thankfully, Frances was the person who came forward about this. And by the way, why was it Frances Arnold's fault? that people in her lab fabricated results. Why was it her fault? And think about the role of your research advisor here at ASDRP. If one of you were to fabricate results, that would fall not only on your head, especially hard, but it would also fall upon our heads. She was their advisor. She was responsible for supervising the credibility of the science that was disseminated. Good, perfect, exactly. People understand that. That's very good. So that's important when you submit work in the context of knowing that everything that you submit, including the NMR spectra, the code, every single piece of whatever you submit is going to be inspected to utmost detail by highly trained scientists in the field. That's the beauty of peer review. And any scientist looks at that with a respectful fear and trembling, knowing that that is how science moves forward. But that is also how a lot of people get caught red-handed for being poor scientists. Okay, so that's that. Last but not least, how does one get good at writing a manuscript? Read the literature, critique yourself, ask for help if you need feedback, spend time refining ideas and words. Let's see. I'm going to pick on somebody else who is in like, I don't know why people are logging off because this is not over yet. Jesslyn, is Jesslyn here and paying attention?
Yeah, hello?
Yikes, hello.
Hello.
How many back and forths does it take between the time that you put a manuscript in front of me and the time that we hit submit to a journal? You authored a few, several.
It depends on the paper. So like I know some papers probably took like maybe like a month, but then other ones we had to change a lot of things, so it took way longer.
Yep. So the best way to get good, thank you. The best way to get good at writing manuscripts is to read lots and lots of manuscripts. And this is the same thing with colloquium, right? Why do we make attendance mandatory? It's not to take up 2 hours of your Tuesday evening, but because the only way to get good at something is to observe others at how well they did it. Be critical when you read things. I have seen papers, and by the way, I've seen this at ASDRP, where we're reading literature in our group, and then we come across a paper where the authors misassign a paper, misassign a structure. In fact, Andrew Graphite, there's a beautiful NMR of Andrew Graphite on Google Images, and it's on ResearchGate and whatever. And that structure is incorrectly assigned. And we wrote to the journal, and now that paper is retracted. But the best way to be good at writing manuscripts is to read and to read and read and read and read with a critical eye, asking yourself, what did people do well and what did people do poorly? Okay, so we'll be done around 12:15 today. Sahar, do you know how to open rooms on this thing? Breakout rooms.
How to open what?
I got it, breakout rooms. So we have 160 people here. So I'm going to create breakout rooms, 10 breakout rooms. Okay, there are now 10 breakout rooms that are now open, and I would like everybody to randomly assort yourself into one of those 10 breakout rooms. And I will send out the attendance form at the end of this. So once everybody is in a breakout room, then I will distribute the assignment.
This one, the strain-specific and photochemically activated antimicrobial activity of berberin. So what we noticed was that the effects of berberin, it's like the structure of the research paper, it started with effects of berberin, and then it continued to photoradiation, singlet oxygen effects, synthetic efforts, and then potential biological effects. And then we also noticed that they were testing various functional groups and like checking to see their effects on the photochemical activity. There are a lot of visual graphs so that like of the data. And there was a lot of information available to recreate the experiment. And yeah, there was a lot of quantitative data and copies of procedures. And the conclusion was, it didn't like what is the word? It didn't overreach. Yeah, it was like very much in the scope of the research. Yeah.
Good, excellent. And Pratyush is very active, I guess. Next, room 3. Oh, look at that. Minds think alike, don't they?
Oh yeah. Oh wait, okay, hold on. I closed the tab and then I reopened it. Okay. So one thing that we noticed was that there's like 31 cited sources, and most of them appear in the introduction. Because like they're giving a background about the topic. So that's where most of the sources appear. That was one of our observations. And then also, wait, I'm forgetting. Okay, yeah. So also, there are a lot of pictures of concerning the experiment, and those are very helpful to understand how the experiment is set up. Yeah.
Good. Room 4.
Okay, we also shows the same paper.
Oh, no.
So some things we noticed was that the images were really well captioned, so it was really detailed. And also under the characterizations, there's a lot of quantitative data, which just shows like the precision of like the procedure.
Most journals, it is common practice in most journals where you have to specify for every chemical you use, the manufacturer and the quality, purity, and sometimes even the lot number. So, you know, these are just our papers in JEI, but we have papers in other journals that to a greater degree of rigor. Room 5. Don't tell me you chose the same photochemical activity of berberine. Room 5. Anybody? I will pick if nobody volunteers. Maddie.
Okay, can you hear me?
Yes. Oh, there's 2 Maddies in room 5. Yes.
Oh, is that a different meeting?
Maddie's name, it doesn't matter. Okay, nobody wants to talk. Room 6.
Or I can talk about it. I just can't share this.
Well, okay, make it quick then, because we're already at 12.
We talked about like how the references that we're getting, how they cited sources, and how like specific they were about kind of the steps and processes and going over like.
Okay, Maddie, nobody can hear you, so we're gonna go to room 6. Room 6.
I can do
Let's
it.
look for a better microphone. Who's gonna screen share?
I can do it.
Oh, very good. Go. Ah, another homology modeling.
Yeah, can you guys see my screen? Okay, so yeah, we did the homology one. And for the introduction, one thing we noticed is that there's like a hook which grabs the reader's attention. And then if you scroll down to like the data tables and like the molecules, we notice that they're all like really like well drawn and like they're all like really specific. And then over here for like the data table, we'll notice that the mutations are color coded, which makes it easier for the readers to analyze the data and stuff. And then for the references, what we notice is the references are a combination of scientific paper and website and are arranged in order of when they appear in the paper. And all the referenced information are cited using parentheses right after the information is presented in the paper. And another thing we notice is that the materials and methods section is after the discussion section.
Excellent. That's very good. And by the way, those formatting things are journal specific. So when we submitted work to the journal Student Research, that had a different format. We're currently preparing a manuscript for Beilstein. That's a different format. Yeah, room 7. And by the way, if you haven't done so already, the attendance form is in the chat window.
Can you see my screen?
Yep.
Yeah, so we chose the computational structure, the DNA binding one. So something we talked about, we took a look at both the PDF version of the paper and also the page with the summary and the abstract thing. And one of the things that we recognized was that for the summary, it's sort of formatted in a way that starts with the basic information about the main concepts dealt with in this paper, and then it kind of moves on to more specific logistics and procedures that were used, which kind of builds onto each other. And then also for this visual, I'm pretty sure it was created by the investigators. That's what we thought. So we thought it was interesting that instead of using the ones that are out there in the internet, they kind of visualize their own procedures based on using their own visuals, and that kind of made it easier to understand the entire context.
So let me pause you right there. Why is it not only good but also mandatory that the authors on that paper created their own figures? All of these figures that people are screen sharing, these were figures that were created by the student authors. They were not from Google Images.
Is it because it's not a review paper, but it's they're actually doing their experiment and they actually found it's their discovery, so they also have to be creating their own visuals and figures?
Exactly. Perfect. Good. That paper is copyrighted to students who made who made that work possible. So not only is the text copyrighted, but also the figures. But yes, exactly. That's a very good observation. This is room 7, room 8. We're almost there. Room 8. Room 8. If nobody wants to go, I shall call on someone. Oh, Kim, thank you.
So we chose the research paper, which was high throughput virtual screening of novel rilberine analogs as next generation antiretroviral therapeutics. And then so we basically noticed how they do a good job explaining the effect of HIV in the intro. And the visuals, the pictures and charts, they help make the results and other parts of the article easier to read. And in the summary, it's not impossible to read for non-researchers like most papers. And they avoided purple prose and did a really good job explaining it in a way that everyone would understand.
Good. I mean, this is important in science, that people are explaining their work in a means that is understandable and appreciable by other people who do not have the same background. Yeah. Our reviewers for this particular paper, all 3 were molecular biologists and virologists. 2 were at Harvard, our reviewers for this particular manuscript. And it was through many rounds of review that abstract was crafted the way it is. So, good. Room 9? Oh, that was room 9. Was that room 9? I guess we're not onto room 10.
That was room 8.
Oh, okay, room 9.
Hi, I apologize for the background
Really
noise.
like HIV, huh? Nobody picked.
Yes, it's another homology study.
Okay, cool.
So the observations we had were kind of similar to room 8's in that we also found that there was a lot of helpful charts and diagrams and tables that really helped the rest of the paper, and that the beginning made a really good introduction because it immediately began with the prevalence and significance of HIV and explaining why the research was relevant. We also found that the methodology was described in such a way that provided a lot of operational definitions, so the experiments could be replicated. And in general, we saw that a lot of the sentences tended to be pretty long because everything was so meticulously described.
Good. Yeah, I mean, the computer modeling, this is a big challenge for all of you who are sitting here as computer scientists. One of the biggest challenges in peer-reviewed literature in computer science is how do you benchmark reproducibility in code? Not only code, but the results of, it's a big discussion right now within the machine learning community, one that now we are touching upon. Good, thank you. Great, room 10. And then you will all be off to your Saturdays.
Okay, so some stuff we noticed.
I can't
we
really
noticed,
see your. Oh, there you go. Now it's. Oh, we like.
okay. Yeah. So we noticed that the summary, as group 8 said, was like super clear to the reader, even if they weren't like really familiar with this topic. And we noticed that they talked about like the use of this compound in like history, and then they led that into like the rest of the introduction. And we noticed how the discussion was before the materials and methods, and that like usually wasn't the structure in like other things we read. And the graphs were all like super clear to the reader. And the whole article was just like really detailed and described everything in great detail. Yeah.
Good, and I'm glad you noticed, I think you noticed, hopefully you noticed the error bars too. These, we initially submitted this paper and the error bars were too big. So the reviewers came back and said, we want you to redo all the experiments a few more times. So I think we ended up doing each one of those 9 times over. And that took a long time, but we have great confidence in the results because it's been reproducible that many times in our own hands. Great. Okay, so don't forget to fill out the attendance form. Great job on sticking through a 1 hour, 40-minute seminar. I was giving a seminar this morning to a bunch of. Let me stop the recording.